In this video, we're going to look at binomial probability, a situation that occurs when we have two outcomes that are equally likely. For example, flipping a coin. We have two outcomes, heads, tails, and they are equally likely. Another example might be having a baby. You could have a boy or a girl, and those outcomes are equally likely. Let's take a look at an example. An unprepared student is going to take a quiz that consists of 3 true-false questions. They have to answer by guessing. First, let's take a look at how this fits into being a binomial probability question. For each question that they answer, their response is either going to be correct or incorrect. Those are the two outcomes. And since these questions are true-false, that means they have a 50% chance of getting it correct, which means correct and incorrect are equally likely outcomes. So here we have two outcomes that are equally likely, so it's a binomial probability question. Now let's take a look at how we're going to solve this thing. We can see here that we have 3 trials. We have 3 questions on the quiz, so we have 3 trials, which means we're going to use the 3rd row of Pascal's triangle. So when we do that and we set up Pascal's triangle and we go down to the 3rd row of Pascal's triangle, and we can easily see that it's the 3rd row because the first number after the 1 is a 3. So that's the 3rd row of Pascal's triangle. Now as we go across here, this isn't a necessary step, but I think it's really helpful to label. The first one that we come to tells us the number of ways that the student could get 3 correct answers. Then this 3 tells us this is the number of ways that they could get 2 correct, the number of ways that they could get 1 correct, and the number of ways that they could get 0 correct answers. So all the possible outcomes that could happen are across that row, and when we're looking for the probability, remember that probability is going to equal successes divided by outcomes. So what we need to do here is we need to figure out our successes and figure out our outcomes, and that's how we'll have our probability. Now our question here said, what is the probability that this student will get exactly 1 question correct? One of the things that gives students trouble in binomial probability questions is the difference between the words exactly and at least. What I want to say to you guys is that in these questions, these words mean the same thing as they do in your daily life. If I were to tell you that a friend of mine has exactly 1 child, you would know what that means. They have 1 child, no more, no less. If I were to tell you that a friend of mine has at least 1 child, well, they could have 1, or 2, or 3, or 4, or more than that. So exactly means exactly, no more, no less. At least means that much or more. So exactly 1 question correct. What we've been given in this particular question, what is the probability that they will get exactly 1 question correct, means the only successes we will find in our table are where they have 1 question correct, no more, no less. First, let's find our number of outcomes. Our number of outcomes is going to be the sum of all of these numbers in this row. So I've got 1 plus 3 is 4, 5, 6, 7, 8. I have a total of 8 possible outcomes. Then I need to identify my successes. Where are my successes in this table? And I go looking across and I see here, that's the number of ways to get 3 correct answers. That's not a success here because remember, I need to find the places where they get exactly 1, no more, no less, correct. 2 correct answers. No, those 3 outcomes are not successes. There are 3 ways to get 1 question correct, and that is what I'm looking for. Exactly 1 question correct. So this is going to be a place where we see successes. And then finally, 0 correct. Is that exactly 1? No, it's not. So I have 3 successes and 8 outcomes. So the probability that this student will get exactly 1 question correct is 3/8. Here we're going to look at the exact same situation with one minor change. An unprepared student is going to take a quiz that consists of 3 true-false questions. They have to answer by guessing. That 3 in green tells us that we are going to need to go to the third row of Pascal's triangle because we have 3 trials. So we need the third row of Pascal's triangle. This 1 tells us how many ways can they get 3 answers correct. The 3 tells us how many ways can they get 2 correct, how many ways can they get 1 correct, and how many ways can they get 0 correct. If you struggle with these, putting those labels on Pascal's triangle is a really helpful step, and I encourage you to do it. Our question now is, what is the probability that this student will get at least 1 question correct? So let's see, now instead of exactly 1, no more, no less being successes, now it's at least 1 question correct. So that's 1 or more questions correct we will consider successes. We know probability is successes over outcomes. So first let's find all of our outcomes. And that's the sum of all these numbers. 1 plus 3 is 4, 5, 6, 7, 8. I have a total of 8 outcomes. And now let's see, where are my successes? So I need to find those. Here I have 3 correct answers. At least 1 was the condition I was looking for. At least 1 means 1 or more. So yes, successes. 2 questions correct. At least 1 is a success. So 1 or more is a success. Yes, successes. 1 question correct. Let me see, at least 1. So they have to have 1 or more. So would 1 question correct be considered a success? Yes, it would. So these are considered successes. And then finally, 0 questions correct. I needed them to have at least 1 or more. So those are not successes. So the number of successes I have is 1 plus 3 is 4 plus 3 is 7. So I have 7 successes. The probability that they will get at least 1 question correct is 7/8. Let's look at one more. We're still looking at our unprepared student, but this time an unprepared student is going to take a quiz that consists of 4 true-false questions, and they have to answer by guessing. What is the probability that this student will get at least 3 questions correct? Well, the 4 tells us we have 4 trials. They have 4 questions to answer. So now, instead of looking at the third row of Pascal's triangle, we have 4 trials. We're going to have to look at the 4th row of Pascal's triangle. Again, we are looking at probability is going to be successes over outcomes. So here, the first thing I need to do is figure out how many outcomes do I have? Well, I have 1 plus 4 is 5, plus 6 is 11, plus 4 is 15, plus 1 is 16. I have a total of 16 outcomes. Now, what do those outcomes represent? Well, this 1 tells me the number of ways that I could get all the questions correct. That would correspond to 4 correct answers. And then that just reduces by 1 right down the line. The 4 tells us the number of ways I could have 3 correct. The 6 tells us the number of ways I could have 2 correct. This 4 tells us the number of ways I could have a 1 correct. And finally, this 1 tells us the number of ways that I could get 0 correct answers. Now I have to go find my successes so that I can answer my question. So, let's see. My question says, what is the probability they will get at least 3 questions correct? So that's 3 or more. So if I get 4 correct answers, that's a success. What if I get 3 correct answers? Well, this says at least 3. That's 3 or more, so 3 is enough. So 3 questions correct, those are successes. 2 correct answers, not enough correct to be a success. 1 correct, not enough to be a success, and 0 correct, not enough to be a success. So the successes I have are circled, and I have 1 plus 4. There are 5 different outcomes that would be successes. So the probability that I'm going to get at least 3 questions correct is 5 out of 16. Use Pascal's triangle carefully. if you have trouble, make sure to add these labels because I really think you'll find them to be helpful. Be careful with the difference between exactly and at least, and I think these will go pretty well for you.